Exo and endo products in Diels Alder reactions. Here is the Diels Alder reaction that is happening between 1,3-cyclopentadiene and this dienophile to give us two bridged bicyclic compounds. Let's see how these two products are formed and why this is a major product. Okay, let's first give the numbering on 1,3-cyclopentadiene. We're going to assign this carbon to be number 1, 2, 3, 4. For now, we'll not be worried about this carbon since these are the two carbons that will be reacting with the dienophile. Let's go on to the dienophile, and here we are going to use some alphabets. We'll label the two carbons that will be participating in the Diels Alder reaction as carbon A and carbon B. Now we needed to find out which of these two carbons is electrophilic. Because you do have an electron withdrawing group here, the electron withdrawal can happen through resonance, right? It can be pushed onto one of these oxygens right here, right? So because of which this carbon right here is electrophilic. It's going to have a partial positive charge on it. So either carbon 1 or carbon 4 can go and attack this carbon. Since this is a symmetrical structure, we'll not be worried about it. We'll go have this carbon make a nucleophilic attack on this carbon of the dienophile. So let's show the electrons here. So this is going to make a nucleophilic attack on this carbon, and that's going to push the electrons from the pi bond to go make an attack on carbon 4, and this pi bond is going to break and a new pi bond will be created in place of it. So we'll be creating a new bond between carbon 1 and carbon 2, and this bond is going to break, and there will be a new bond between carbon 4 and carbon B. And there will be a new pi bond between carbon 2 and carbon 3. So these are the new bonds that are created. Let's write down the product that is obtained. First, we'll draw only the skeleton of the diene and the dienophile, and then we'll put the double bonds later on. So here is carbon 1, 2, 3, 4. And this one right here is carbon A. This is B. We said that we wanted to connect carbon 1 and carbon A, right? So let's do the connection here. And then we are also going to connect carbon 4 with carbon B of the dienophile. So let's also make that connection. And then we have to put a double bond between carbon 2 and 3. So here is the product obtained, and you can see that these are the bonds that are created. There are two new sigma bonds, and there is one pi bond that is created. This carbon right here is carbon number 5, which is from your starting material, right? So starting diene. And you can also represent these bonds with wedges, showing that it is coming towards you. And these two 5-member ring structure. Okay, these are two 5-member ring structure. This is one, and this is the other one, which is fused together. And here are the bridgehead carbons. These two carbons are shared by the two rings. And therefore, this is our Diels Alder adduct. There's one more way to draw this bridged bicyclic compound. That is to draw the 6-member ring structure first. Okay, let's draw the 6-member ring structure. Okay, and this is our carbon 1, 2, 3, 4, and this is carbon A and B that is from the dienophile. And we do have a double bond between 2 and 3. Let's draw the double bond, and what is missing here is only this 5th carbon. So this is carbon 5 from the diene, right? So let's draw that. That's going to be up in the air. So this is carbon 5. Now what is missing in here is only the substituent that is present on the dienophile, the substituent. Now there are two different ways that substituent can exist in. It can exist towards this double bond, or it can exist away from the double bond. So if it exists toward the double bond, then it's called as an endo product. This one right here is the endo product. And if it exists away from the double bond, then it's an exo product. In general, in Diels Alder reaction, the endo product is more preferred because this developing double bond is going to have some interactions with the carbonyl group of the substituent when it is pointed down. Here are the transition states for the two products. Let's number these carbons. So here we do have carbon 1, 2, 3, 4, and this is carbon 5 of the diene, and this is carbon A and carbon B of the dienophile. As the dienophile approaches the diene, it's going to have some interactions between this developing double bond and the carbonyl group, and therefore it will be stabilized. But here, that's not the case. And this situation where the endo product is formed in preference to the exo product in the Diels Alder reaction is called as endo rule. And when you look into the products that are formed in this Diels Alder reaction, you can see that this is the endo product and this is the exo product, and the endo product has been formed in major amounts compared to the exo.